Right, welcome dear students. This is your probability series and we are on our first lesson. So here I'm going to teach you some terms that we're going to use on probability, and then towards the end, in fact midway, we are going to do the questions themselves. So let's quickly learn a few things about probability. Firstly, let me define it for you. Normally, when we say probability, we are just talking about the likelihood of an event happening generally. So let's just say the likelihood of an event happening. Okay, we're going to define it like that. So if your event is E, so if you want to calculate the probability now, you do it this way. So if your event E, if you want the probability of E generally, you should say the number of outcomes for event E over the total number of possible outcomes for this in the sample space. So in other words, in short, I'll write it like this most of the times. That is the number of outcomes in E, so it will be like this, and then over the number in the sample space. So it's simple like that. You already know these things. However, I just want to mention that let's just say you were in a classroom where there were 20 girls and then there were 15 boys. And then my event is you picking on a girl. If everyone is equally likely to be picked, what is the probability that you'll pick on a girl? Well, if you pick someone from this class, what the probability of picking on a girl is the number of outcomes for girls, that is 20 divided by the total here. The sample space is the total of everything. So in this situation, that will be 35. Okay, so if you want to simplify that, feel free to do so. 5 will go 4 times here, and it will go, 7 times in that one? So it will be 4 over 7. So that's probability in general. You just calculate it like this. So since you already know this, let me just remind you some of the expressions that we were using, rather the terminology here that we use in probability. Say, for example, I talk of 2 events. We're going to name them A and B, and if we say that the events are mutually exclusive, in other words, those 2 events cannot take place at the same time. All right, so that means the probability of A and B is equal to 0. They won't take place at the same time. So if you want to think of any 2 events that may happen and may not be able to take place at the same time, think of something. And I'm thinking, if you're driving a car and you get at an intersection, you can perhaps turn left or turn right, but you cannot turn left and turn right at the same time, isn't it? So because those 2 are mutually exclusive. If the event of turning right and the event of turning left, those ones are mutually exclusive. However, I don't want to say they are exhaustive, because then someone may just go straight as well. We will talk about those type of things later. So do think of something else that is 2 events that are mutually exclusive, and I would like to hear from you if you can tell me. Right. And another thing, perhaps you can either just be a boy or a girl. Those 2 you cannot, but maybe let's not include that one in here. Let's talk about turning. It's easier to see things that way. All right, so let's have other terms that are included here. The reason I removed the boy and girl is because we also have what we call complementary events. So generally, if you want to talk about complementary events, just know that, again, these 2 events they cannot possibly happen at the same time, but the difference between complementary events and mutually exclusive events is that these ones are exhaustive events. So it's either that, if you sum the 2 events, let's say here, if they're events A and B, the probability of A plus the probability of B should give you the full set. That is the part that's what we mean by exhaustive, right? So they'll give you the whole sample, right? So how do you get it right? I always say, if you talk about probability of A, which we normally do not like this, then talk about the probability of not A. Otherwise, if you talk about something else, those two may not add up to 1. Like, think, for example, the example I told you of mutually exclusive events. A person, let's say the probability of turning right and the probability of turning left, those two, they may not be equal to 1, because I'm saying that there is also another chance that one person may go straight at that intersection. They may carry on straight. So if you get at an intersection such as here, I'm saying, if you're coming from this side, you have an option to turn left or turn right, or you may go straight. So I'm saying if this is left and this is your right, I'm saying it's not exhaustive, and therefore we cannot say those two events are actually complementary. But how can we get complementary events? If you say the probability of turning right and the probability of not turning right. So if you know the probability that a person turned right, and then the probability, everything that's left is the probability that the person did not turn right. So that's what we mean by complementary events. So notice here on your notes that I put over here, we're saying if two events are complementary, which is up here, notice the probability of not A can be represented by that, which means it's 1 minus the probability of A. Okay, so probability of A and the probability of not A are complementary events. It means they add up to 1 at the end of the day. And please notice one thing. All complementary events are actually mutually exclusive. They cannot happen at the same time. So we are saying you are either a boy or you are not a boy. So that those two are complementary events. So you can say boy, girl, but again, you don't want to put it that way. So I prefer you say probability of picking a girl and the probability of not picking on a girl. That is what is equal to 1. Where some people may argue and say probability of not being a girl would necessarily mean that the person is a boy. So you can also put it that way. It could be fine, right? So think of any two events. So if I say the probability that it's raining, the probability that it will rain is equal to, let me say, 0.2. So what it means is that automatically I know the probability of it not raining. I just have to subtract from 1. So when I say not, it means 1 minus whatever happened before. So those events, those kind of events, we say they are complementary events. And all complementary events are already mutually exclusive, which means they cannot take place at the same time. All right? Let's have another expression to explain quickly. We also have dependent and independent events. So for the sake of time, I decided I'm going to give you these notes. Look, two events are said to be independent if the outcome of one event does not affect the probability of another event occurring. Okay? So if you have two events that do not affect each other at all, those ones are actually independent events. So think of any two that will not affect each other, and then you may actually let me know. So I may mention that if you're tossing a coin, whether you get head or tails on the first toss or on the second toss, it doesn't change. Let's say at first you get a head. It doesn't mean that maybe in the second time you do it, the result you got for the first one may affect how the second result. No, that won't happen. So the probabilities will just be independent like that. So that is one example. So think of other examples and let me know. Right, so what is that one thing about independent events that is actually interesting? Well, I think you understand that if independent is being defined like this, it means that if the event, the probabilities do affect each other, then we say that they are dependent on each other, okay? So maybe you're thinking of an athlete running. Maybe the probability that they actually win may not be independent from the fact that there are people cheering them on. So if you cheer someone on when they're running, apparently I guess it increases the adrenaline pumping, and it may just increase or improve the way they perform on the day. So those ones we may say they are dependent events. And maybe what is the probability of you passing a test if you were watching TV the previous night for 5 hours? Well, you know that those two events may affect each other. If you've been watching TV for such a long time and not studying, most probably you're not going to do well in the next test, unless if you're, there are those, the genius, a genius right there. So let's just quickly see what's what here with the independent events. Please notice this is the rule I want you to know. So if two events are independent, this is true for them. Probability of A and B will be equal to the probability of A times the probability of B. That's what you must remember. So if you know that there is the probability of a certain event, let's call it A, and let's say it was 0.3. And then you know that the probability of an event, which we call B, maybe it was 0.2. So if you want to calculate the probability of A and B happening together at the same time, all you need to do is to say 0.3 times 0.2. Okay? So that should be easy for you to calculate. Okay. Just making sure of things. So as you can see, you got your 0.06 right there. Right. So now that you know what mutually exclusive, and by the way, do you still remember? If they are mutually exclusive, the probability of A and B is actually equal to 0. Don't forget, this is for mutually exclusive events, the one that we started with. Okay, just reminding you already. So this works, this particular one right here, it works for independent events. Okay, well done. I think you're getting this. Now, we would like to just now talk about the addition rule, which is the last thing I want you to remember. So you did the addition rule now, where we have or in between. What is the probability of A or B happening? So as you can see, this will be the formula right there. You just add the probability of A to the probability of B and subtract the intersection of the two. So you can as well write it in this format where union means or, right? And then when you say and, that's the intersection right there, right there. That means the intersection, it means and. So if by any chance, let me just say for mutually exclusive events, if you by any chance have mutually exclusive events, there is something that we already know. What do we remember about mutually exclusive events? Well, they cannot take place at the same time, and the probability of A and B is equal to 0. Okay? So if I go and substitute this back into that formula, what I'll then get is, for mutually exclusive events, if I want to find the probability of A or B, all I need to say is probability of A plus the probability of B, like this. And the probability of A and B will be 0 over there. So I won't have to include it, because it will be 0. For mutually exclusive events. Well, then what do you do with that if you have independent events? Well, for independent events, all you have to remember is that the probability of A and B, which is this last part over there, should be probability of A times probability of B. So let me just rewrite that one as well. So if they are independent events, this is what you will be expected to remember, okay? And then in place of probability of A and B, you put probability of A times the probability of B. Okay, so what you just have to remember is this formula. I believe they give it to you at the back of your question papers, but if you're in lower grades, you'll do well to remember this. Okay, so why don't we use this in actual questions then? These expressions, complementary, mutually exclusive events, and then, independent events. What do we do with them? So here is a question. In fact, I'm already showing you 2 questions here. If you would like to try the first one on your own, feel free to do so, but I suggest let's do this first one together. Okay, so let us see how we are going to answer this one. So the first question says, probability of A was given, probability of B was given. We want to calculate the probability of A or B. Under normal circumstances, we just say probability of A plus probability of B minus the probability of A and B. This is the formula. Now from here, you just make your substitutions. So probability of A was given to us to be 3/10. The probability of B there is 1/2. But because we were told they are mutually exclusive, we know that this part is a 0 over there. So just quickly add those two on your calculator, just like what I'm doing here, and then see what you get as well. Okay, I'm getting 4/5. That is the answer I'm getting. Well, let's go to B now. Now B, we still want to calculate the probability of A or B. I believe you know now that if I was going to copy this equation as it is here, this top equation, but I just feel since we already know the equation, I can as well just put probability of A and B as probability of A times the probability of B. Why am I doing this? Because I was told the events are independent. Okay, so let's put the values in. In place of probability of A, well, there is 3/10 plus probability of B, which is now 1/2, minus, let's put this in, probability of A is 3/10 times 1/2. This should be easy to handle. Okay. I believe we added that one before and got 4/5, right? So we just have to subtract that. Okay, let's see how that will work. So what are we subtracting in actual fact? We are subtracting 3/20, aren't we? So it's 4/5 minus, okay, I'm getting 13/20 here. So I hope you have the same answer. So I want you to try the next one using what we just learned, how to answer these questions. Go to number 2 quickly and answer that one as well. Just number 2. Go ahead and try it. Well done if you tried it. So now let's answer it together and see what's going on here in question 2. So you're supposed to determine whether events A and B are independent or not. So what it means is that you have to find the probability of A and B. That is what you have to find. This is what you want to find. So that if you find it, you compare it with the probability of A times the probability of B. So those are the two you would like to compare. If ever these two values, the value of probability of A and B is equal to the probability of A times the probability of B, then you can say their events are independent. If they are not equal, then forget it, it's not going to work. So let's go ahead and do it. All right, so we are going to use our formula because our formula says probability of A or B is going to be equal to probability of A plus the probability of B minus the probability of A and B. Okay, so let's put in the values quickly. I'm going to put 0.428 here, and then is equal to probability of A 0.12, probability of B 0.35 minus the probability of A and B. So if I dare put probability of A and B this side, I believe I'll have to just subtract those ones. So let's go and first of all, it's 0.12, right? And 0.35. Then we have to subtract 0.428. Okay, I'm getting some 21/500. Let me see. It would be fine if I write it like this, I think. Okay, so that is the probability of A and B. Well, now that we have it, let's keep it here with us so we can compare these things later. So what do we want to do now? We want to find the probability of A multiplied by the probability of B. That's what we want to find right now. So what is the probability of A? Well, that is 0.12. What is the probability of B? That is 0.35. So let's compare those two answers. So it will be 0.12 multiplied by 0.35. Okay, I'm getting 21 over 500, which is actually equal to 0.042. Well, because probability of A and B happens to be equal to probability of A times the probability of B, because 0.42 is equal to 0.42, isn't it? So therefore, the events are independent. That is all you have to say here. Okay? So, done with that one. So let's see how well you can do the rest. Feel free to do question 3 first, and then see how I will answer it. Well done if you tried it. So here we have A and B, which are two events. The probability of the event A, that event A will occur is 0.4, and the probability that event B will occur, let me just write that one down, is 0.4, and the probability of B is given to be 0.3 over there. And what do we need? The probability of either A or B. A or B. What is this? It's 0.58. Well, once this information is given, so let's just make sure we are getting the statement. What does it say? The probability that either event A or event B will occur is 0.58. Okay, perfect. We have the statement right. Okay, let me just put these away. Right, what do we want to do with our life right now? The question said, are events A and B mutually exclusive? That's the first question. So, are they mutually exclusive? You have to mention yes or no. Well, to figure that out, to figure out if events are mutually exclusive or not, you need to find the probability of A and the probability of B. If this is equal to 0, then the events are mutually exclusive. If it is not equal to 0, then the events are not mutually exclusive. So let's go and let's use our formula for that. It doesn't look like we have probability of A and B right here, so we may have to calculate it. So this is what we have, right? Making substitutions, I'll put 0.58 here, and I'll put 0.4 here, and 0.3 here. I think I'll easily get this remaining one. Okay, so you know what I want to do here. Let's see if we'll get a 0 or not. So what do? You say 0.58, or in actual fact, you want to say 0.4 plus 0.3, and then you have to subtract 0.58, actually. So I'm getting 3 over 25 here. And 3 over 25 is definitely not equal to 0. So because I'm getting something that is not equal to 0, I know that events A and B at this point are not mutually exclusive. Okay, so events A and B are not mutually exclusive. Why am I saying this? Because the probability of A and B is not equal to 0. Okay, this is definitely not equal to 0, as you can see. All right, so I can see they are not mutually exclusive. I know the probability of A and B happens to be 3 over 25, which is 0.12 here. You may do it that way. Now, here is another thing. Are events A and B independent? If you want to check that one, you use this formula. This is for independent. So you're going to say for independent events, probability of A and B is equal to probability of A times the probability of B. So you have to check if this is the case. Okay, for independent events. So I'm going to put the probability of A and B. Remember, it was 0.12. That is the value for 3 over 25, right? So it's 0.12. Let's see now if the left-hand side will be equal to the right-hand side. What was the probability of A? Have to find it. Okay. Now looking at this, I can see the probability of A must have been 0.4. And the probability of B must have been 0.3. You seeing where I'm pulling them up? So multiplying those two, let's see, 0.4 times 0.3, I am getting the same 0.12. So as you can see, these two are equal. So because the left-hand side happens to be equal to the right-hand side, which means probability of A and B is equal to probability of A times probability of B, therefore events A and B are independent. Okay? I hope you're following. All right, so here is another example for you. Do this question on your own and let's see how well you can do this. Well done if you did it on your own. So here we have for any two events A and B given, we were given that the probability of A and B is 0.12. We are certainly going to need this. And the probability of A or B is given as well. Oh, and we were given the probability of the relationship between these two. So please keep those in mind. Right? Here is the first question. Are events A and B mutually exclusive? I would say no to this. Why am I saying so? Look at the probability of A and B. Can you see that it's not 0? So because the probability of A and B is not equal to 0, it is actually equal to 0.12. So as long as those two events can happen at the same time, that means they are not mutually exclusive. Okay? So they are not mutually exclusive, these ones. Right. Now that we have that, the next question we are being asked here is to calculate the probability of B. For questions such as this, you have to fall back to your addition rule, this one. It usually takes care of everything. All right, so how are you going to handle this? You substitute whatever you were given. Like now, I was given 0.83 for A or B, so I'm putting it there. I was also given the probability of A and B, so let me be quick to put it in. It's 0.12. What else was I given? Was I given the probability of A? Well, I wasn't, but I was given something over here. So it appears like I'll have to keep the probability of A. What could you say here? What do we want to calculate? We actually want to calculate the probability of B, but it does look like we may have to go via calculating the probability of A. It's fine. Let's go via that. Probability of B is actually 4 times the probability of A. That is what we were told in the statement over here. Right? I hope you're following. I'm trying to see it myself as well. Right? So here this is 4 times the probability of A. 4 plus 1, that's 5. That's like terms. So let's add those two. 0.83 and let's add 0.12, right? So I'm getting 19 over 20. I like fractions, so I'm going to keep it like that. So the probability of A, I'll have to divide that by 5, right? So that would be 19 over 100, 0.19. So I have my probability of A, but I wasn't asked for the probability of A. I was asked for the probability of B, but the probability of B is 4 times the probability of A. So it means I'll have to say 4 by 0.19. And what will I get? Just multiply that thing by 4. You'll get 19 over 25, which I'll write as 0.76 for now. Okay, I do actually prefer fractions. Now, lastly, for this question, you were supposed to calculate the probability of not A. Well, if you remember these now, we are talking about complementary events now. If we say probability of not A, it means it's 1 minus the probability of A, because complementary events are exhaustive. All right, they will add up to 1. Probability of A and the probability of not A should add up to 1, complementary events. So it will be 1 minus the probability of A, which we calculated to be 0.198. over here. Okay, that's where it is. So let's go and say 1 minus 0.19. Okay, so it does look like that would be 0.81 right there. All right, so let me give you the last question. Otherwise this will get too long. So I'm not thanking you yet. Let's do question 5 first, and then I'll be sure to thank you after that. Right, so here we have question 5, and well done if you tried it on your own yet again. So here we have probability of A, you have probability of B, and you want to determine the probability of A and B if A and B are independent events. The moment they tell you that they are independent events, you must remember that this formula applies. This becomes very true the moment they are independent. Okay, so if that's what you want to find, all you need is the probability of A, which is 0.48, and the probability of B, which is 0.26, and then you go for it. Okay, 0.48 times 0.26, that should be some 78 over 625. Oh my, maybe I should write it as a 78 over 625. Let me just write it as 0.1248. I hope. You can write it as 0.12 really if you want to write it to 2 decimal places, but I'm feeling uncomfortable rounding it off. So what about the probability of A or B if A and B are mutually exclusive? The moment they are mutually exclusive, this right here becomes 0. So that's for mutually exclusive events. So if you want probability of A or B now, it means all you need to write is probability of A plus probability of B, because you don't have to subtract the probability of A and B because it's 0. Okay, so now you just have to say 0.48 here plus 0.26. Okay, 0.48 plus 0.26. That's 37 over 50. You may leave your answer like that, or you may write it as 0.74. Nobody will mind. All right. So please, people, that's all I had for you for this lesson. So it was a first lesson. I hope you remember. What I want you to take home is your independent events. Probability of A and B will be equal to probability of A times probability of B. For complementary events, the probability of an event happening, let's say probability of E, will be equal to 1 minus the probability of not E in general. And then remember your mutually exclusive events where the probability of A and B is equal to 0. All right, thank you very much for watching this video.